afternoon dev session. And that is perfect timing as well because we have pretty much this whole set of experiments done. Oh, that's interesting. We've got this, like, these two peaks at 10 mil and 5 mil now, with nothing in between. You see that? That did something very weird. Okay, so let's actually compare this now to, let's compare this to the previous one. I believe it's this one here. Okay, so this is the one from before on the right side. I can find the Pareto front. I believe we got a solve in, well, this is sys running time. Wait, what? Hang on a second. What in the hell? Sub 20-second solve. We have a several actually, sub 20-second solves. This one is about 30-second solve. Okay, that is crazy. And then oddly enough, it didn't do, it didn't do anything out here, but I mean, do I blame it? It's frickin' solved it in 20 seconds. Like, consistently. I don't see anything in the 21 range, I don't think, but 20.6. Yeah, 20.6. Okay. And then it still goes down to 5 mil. That is nuts. 20-second palm. I'm really curious to see what's different here. Okay. Learning rate. This one finds 0.004 about. This one doesn't do as well over there. Though, I mean, it looks like it just didn't fill in a gap, but there's definitely, a different peak here. That's very weird. This one, it seems like it's getting better. Huh. And then gamma. Okay, gamma is just pushed all the way to 0.999 here. Gamma is a stable region here. Okay. Lambda. 0.95. There are a lot of experiments around here. Again, sort of like a wider spread. Update epochs. Mostly 1 or 2. Okay, so this one has landed on 2 epochs consistently. We had some of both of these. Mostly 1, but some 2. Value function coefficient, 0.6. There are actually several slightly different points here. 0.6. And here, actually we do have the best points around 0.6. Okay. And then the maximum gradient norm. 0.9. And here it's, yeah, this is very different. Okay. Entropy, 0.0005. I mean, this one's pretty stable, so you can't really look at that much. This one probably doesn't matter very much. It's just more samples here, so at 32, whatever. And then we'll do Pareto cost last. I want to look at num-m's and the other scaling params, because those are going to be different. Okay, so here, they actually both find the best around 512m's, right? That size? Yeah, these roughly agree. So, mini batch. This does use bigger mini batch. That could be the speed difference, for most of its runs at least. Sweep cost of 20. This does put runs down to 20, but they're not good. Huh. We still have this sort of problem over here. Man, that's so weird. Like, holy. We get a good result, but the opposite of the result I expected. Welcome, YouTube folks. For those who just popped in, I ran an experiment. We have Pong solved in 20 seconds. But the reasoning behind this is very weird. I'm defining 20, above 20 score is solved here. It's a max of 21. Perfect play would be you consistently get 21. But, generally if you're getting 20 points, it's solved. I mean, we have all these points between 20. What just happened here as well? Did this refresh weird? What's this running time? 22. Cost. There you go, 19-second cost. And this kind of curve is very weird as well. Makes me think you could solve this in like 12 seconds or 13 seconds. Okay, so there are two sort of graphs I want to look at here. So first, where's the score over time? Sweep progress. Okay, this is your sweep progress. Here's this sweep progress. It says far fewer points that are at 20, to be fair. This one has way more points that are at 20. But then if we look at these two curves, this is just finished, so we can have these last few points. You get very different ones. I'm almost wondering if it's worth downloading this data in order to see. Yeah, I think it is. I think what we're going to do is we're going to download this and we're going to look at the sampling distribution here. Maybe we can do something reasonable with this. Hi, welcome. Do we have a... What, this is wand B. I thought there was a script for Neptune that I had. Correlate. Yeah, there we go. The tag here is something. Okay. Get the token. And we're going to do some analysis on these results. And we'll see how we can improve. This also gives a sensitivity for a bunch of stuff, doesn't it? Can we .numpy this? .toList. To NumPy. Yes. Costs, scores. Yeah, that's fine. Yeah, source. Okay. So here's our curve. Interesting that a lot of the latest runs are the bad ones out here. That's really weird. And then I guess if we look at the Pareto points on this, where's costs? This actually has to be a different one. Pareto source. This would be. Okay. So this is what the Pareto front looks like. Cost 20. Hang on. We need both of these. Just copy this. Whoops. I'm just going to do this. Okay. So this curve is just this stretched. Do this. Interesting curve shape. We can also see now with the red which points are more recent on the right. So according to this is not running bad low-cost experiments at the end, right? The thing that I don't understand, right, is why, so you get this Pareto point here, okay, and then you stop trying to expand outward. It's interesting to me that it is actually trying some of these new points, and they're not working. Maybe we need to look at some of those. Hang on, did I switch these windows up? Where's the other window? Because this is the wrong one. So this goes here. So some of these points at the bottom are actually very new, apparently. Like this one or this one here. And they're all new, literally. 821. Wait, what? 8021. No, these are early points. What's wrong? Wait, what? This coloration is wrong. Hang on. Something weird happened. This not get sorted? Oh, is it in a reverse order? Yeah, it's in a reverse order. Okay. So that's going to actually be a very different story. There we go. Okay, so this tells a completely different story then, right? And this is more in line with what we expected from earlier. So this is all good, but then it does this shenanigans at the end. 1, 2, 3, 4, 5, 6. Yeah, lots of these clustered bad experiments here. All very close to minimum score as well. Can we figure out why? Predicted. Okay, so it's going to say predicted. Okay, so it is scoring these things as 0. So presumably they're just a bunch of Pareto points there and it's randomly sampling or something. Maybe we consider this as degenerate behavior. How far up do we have to go before we get a non-zero rating? And I mean, obviously, like, these could have decimals on them, but a meaningful rating. Okay, I mean, this is good, right? Go down a little bit. Yeah, look at this. We're doing well. We're doing reasonable predictions. And then at some point, they're still good at 0. My guess here is that at some point, yeah, you can actually, can you see it? Down here. Right, at some point about halfway through the sweep, boom, we get this collapse. Or at least, it's not a total collapse either. You still have a lot of points up here, but at least it seems like it stops making forward progress. Can we see it on the cost graph? Where's our cost graph? Earning rate. Score. Yeah, cost. Okay, yeah, we can, I think we can see it kind of. Yeah, right here, it goes from this 20 and it sort of splits into 2. Did we have a graph on this? If we only look at till 1:32 p.m., And these freaking scores are like, it doesn't, you can't click them, it doesn't work. So obnoxious. There we go. Yo, I made my PR dev for tower climb. Awesome. We will merge that right now. So you can start playing with it, and we'll make sure it's a clean merge. Test pass, then we will merge this for now, and hopefully they will hope that it just works. Take a quick look. This. Some resources. Upgraded to 5.5. Cool. And you put RPath stuff back in that seems to work, I guess. Wait, is it statically linked still, or did you change that? Oh man, do you have it back to dynamically linked? Let me see. Yeah, you do. Fuck, man. Can you please make it? Okay, so here's the issue, right? The issue is that Python is really stupid, and if you dynamically link stuff, inevitably on some system, it will fuck up and it won't have this on the path. So what happens is as soon as you try to import PufferLib from outside of the PufferLib directory, you get an error, a linking error, because somehow Python has fucked up the path. So that's why we did this, is to avoid that. I don't even know if that's bulletproof. I guess I can merge this. I will just have to. I mean, you've done enough stuff on this, so I will just merge it. Potentially, I will have to do some work, though, and test. Oops. We will get some builds going on this. Awesome there. I'm in the middle of this ablations work, but we will do some testing on your new end quite soon. Because that's a pretty awesome new end. So thank you for that. That was quite a project. Sorry, I got bad signal. Uh, sometimes not. Look, generally just like Python is really shit at linking stuff. So it will eventually mess up your path and cause PufferLib to not work outside the PufferLib directory. I merged it, but there will probably do some stuff, and we do not want it dynamically linked. You replace the .a for static link, you replaced it with a .so. That's going to cause problems, so I'll have to mess with it, but you've done a bunch of work, so I've just merged it for now. Just in dev anyways. Yeah, that would be ideal if you PR that would be ideal for sure. Calling in later, awesome. That'll be good. Hello, trying to create a pufferish hinge. Open to work in progress PR. Yep, let me look. You're gonna end up PRing this probably to dev or something instead of to main. Let me see. Yeah, that's fine. Yeah, I'm looking at it. You can also always just link me your fork. Um, oh, cool. Very nice. We're always happy to have like industry adjacent M's. This is cool. I don't know. I didn't know about this at all. Usually people chat in the Discord or whatever about stuff they're planning on building, but this is a nice surprise. Let's see. Okay, you've just gone from template. Okay. Environment, very good. I'll check this one next and then I'll go up, back up. Doesn't work. You definitely want to have that work as a priority. If you let me know what's wrong with it, you should, yeah, that would be good, because the thing is, building it for Python every time is just miserable. Like, all of your good debug information comes from the C build. Like, it is dramatically easier to write the env in C, build with just, build in pure C, get the actual correct compiler messages and the way faster build times, and then you do the PyX and make it work that way. So I do strongly recommend. Otherwise, it's hard, right? Like, PufferLib is supposed to be easy, but if you try to go through the Python compilation for everything, it's not going to be easy. What are you debugging with? Do you compile with the local mode from the build script? That should give you fsanitize, which will catch pretty much everything and give you nice warnings and error messages. Printf inline. I would suggest using GDB at the very least. Yeah, I would suggest at least just use GDB, and I haven't done any CDev on stream in a little while here, unfortunately. I miss it. But yeah, I generally, what I do is I run the build ocean sh script or whatever, compile the local file, and then I fix any errors that I know how are fixed, and anything I don't know why is broken, I use GDB. Okay, so this is a massive observation space here. If you put data that is this range into a neural network, this needs to be normalized or it'll crash learning. No C experience, we're looking unturbed. So the cool thing about the way that we use C, right, is that we don't do anything that a first-year CS undergrad, having taken their first systems course, wouldn't be able to understand. We're writing if statements, for and while loops, and that's about it. Like, we're using it in a way that is very simple, and it makes it very easy to write fast simulation code without getting hung up on anything. All of the environments that we have serve as examples. Like, you can look at everything from squared for a really basic template, all the way up to like neural MMO3 for something more complex. Max searches plus max trackers. Okay, it's just a single discrete space. Cool. We have a logging thing for this. If you look at any of the environments, there's this like mean and log function. We just have some logging code. You can grab it from Pong or from any of the other M's. It's just in the top of the .h. You can just paste that in, and then you have a little logging library that plays nicely. And see how we integrate that. And that'll let you get all sorts of stats from your environment into the Python very easily and efficiently. Test perf. We have perf test. Cool. Yes. Hey, did you need to do stuff here to make this work? Oh, you just moved. Interesting. If there are compile bugs, we definitely need to know about those. Because we don't want compile bugs. And now your main file. Oh, okay. Yeah, so I think if you're on Mac, you're probably going to want to use a recent version of Clang, because you really, really, really want the F-sanitized flags to work for development. And older compilers, like a lot of the even like pretty recent but not like really recent compilers on Mac, they don't give you F-sanitize. So like C is hard because of buffer overflows and memory leaks and stuff. But the thing is, these don't actually exist if you compile with appropriate settings. You really want to have access to those settings. Ton of constants. Target, got radar. Target, radars, okay. If you say you have no C experience, I mean, you're doing some things here. Unless you were using GPT heavily or something. Like I see just from the types you're using. Snake. Undergraduate C experience is all you need. That's literally all I know as well. Like the thing is, I think that you think that there's stuff that you need to learn here in order to do this. There's nothing else that you need to learn here. Like it's very, very basic C. By design. We don't like fancy things. For context, I wrote Python for the last 10 years, and then I've been writing C in the last 6 months, and it's already easier for me writing like new environments, very complex stuff even in C than it is in Python, using just the utter basics. But you're shooting yourself in the foot not having good compile settings. You're making it way harder than it should be. Stuff like this is fine. What specifically do you want feedback or help for on this environment code? I can just open the full file here. Just first reactions. Yeah, I mean that's it. It's pretty much just like write your C code, like don't compile the Python every time in order to try to dev your C. Use a new compiler, make sure you're using the F-sanitized flags that we have in there so that you actually get good error messages, and just like enjoy writing like really fast code without having to do anything particularly complicated in order to do it. That's sort of the magic of this. Is you can just write really simple C, and PufferLib hooks into the observations of that, so it's able to keep your performance throughout the whole stack. And looking here, I just see a bunch of math, basically, right? I haven't seen anything like particularly major and silly. I mean, it would be pretty easy for me to like get this thing to not be indented 5 layers, but that's just style stuff. Whatever, this silly formatting, but like I'm not seeing anything that's like particularly like there's just a bunch of math logic, right? Just grade school geometry. Yeah, I mean, other than the nesting and the crazy, I don't know if this is your editor formatting or something, but other than that and the crazy spacing, like I don't see anything like intrinsically ridiculous. Like you're not doing any dynamic memory allocations that I've seen, which is good. It's just like a bunch of math logic. Like, yeah, you can probably clean a bunch of stuff up by like caching variables a little bit smarter and stuff. But that's just programming in general, right? That's nothing to do with C. Hmm. 60,000 step episodes. That is something. Yeah, and you're definitely gonna want something like this working. Well, yeah, you can have very long horizon environments. That's fine. How long between rewards is the main question. Like, how long do you go between rewards? That's the thing that matters more. Like, how sparse is it? I mean, like, yeah, we have like we have like continual environments as well. Like the big one that I wrote is this one, right? This is neural MMO3 if it loads. I mean, this thing is pretty darn massive, right? We have way larger maps than this as well. This is just what I could fit on the web. Like all these like NPCs and objects, terrain and levels, economy, all sorts of stuff. And this thing will just keep running. Hey, you kept the puffer color for this. I like that. Rewards related to underlying filter state, just trying to reduce variance. Had trouble learning anything as everything is muddied out to the point actions don't matter. Well, the thing that helps with that, right, is one, having relatively clean environment code, and two, having it be human playable. So that you can like fiddle with your environment and see if you get rewards when you expect to get rewards, right? And you can like look at your observations and make sure that the observations are what they should be. The vast majority of problems in reinforcement learning are your rewards aren't what you think they are, and your observations are computed wrong. Honorable mention to you're not resetting the environment the way that you think. Those are the vast majority of problems in RL. But like the funny thing about that, right, is that that's just straight up, like that's just straight up engineering, right? So you're not really missing any background in order to do this stuff. So I mean, the best advice I can give you here is that other than like compiling it in a way that makes your life easier, you're not really missing anything fundamental. Yeah. You're not really missing anything fundamental. You just need to make your dev life a little easier, clean up some code a little bit, make it human playable so that you can like see what's going on with it. And then once you have that, then if you need some assistance with like getting it to learner stuff, absolutely. But that's what I would suggest doing first. And then this looks like it could be a pretty cool environment. We are always happy to PR new stuff. And hey, if you keep stuff open source like this and you're willing to PR it, then you get assistance as well in integration. So I can help you even get some policies running on this and whatnot. Very good. Go back to the ablation stuff if that's all on this. Yeah, Spencer, if you're here, I got Puffer Box 0 back up and running as well. I need to figure out a couple things with this sweep thing before we really start running experiments, but we now have a box back. And I've gotten the process pretty quick, so if I need to fix any of the other ones, I can reinstall the OS to Ubuntu pretty quickly. We should absolutely put the memory limits on the containers going forward, though. I think you and that guy are just out of memorying yourself into oblivion. Does this could I just train a GP on this real quick? Probably could, right? A little annoying. Yeah. $20 at 19.8. Prediction is just off. Just doesn't know how to improve after this, I guess. Just doesn't know how to improve. I just tweeted something that might be... I might have tweeted the answer to my own problem here last night. Where's notifications from? Weird. Right. Where is it? Here. There's a spread of like 2. It's probably making the Gaussian process never predict. It like can't beat this point, is the thing. And then when we did log cost, why did that cause something different? Because we had something else here. So this is one Pareto front, right? But then we also had this one. No, not this one. So we also had this Pareto front here. This is a 20.4. But the thing is, like, this is 20.4. I think we got a 20.8 or something here, right? Yeah. So it's trying to still beat this thing. 20.4, 20.7, 0.7. And it kind of stops trying, even though it should be easier out here. There's just a lot of noise. It's annoying as well because, okay, continue to play with it. We could run this on breakout to see what it does. Probably just do that. Reboot this frickin' thing. Silly GPU breaking. Token. Prefer to not run this on my local as well. Buffer now. What? The heck? Oh. Nope. Run this on the other box. That way we preserve the local box for whatever I want. Oh, wait, hold on. Didn't push. Okay. Well, we'll leave this alone. I'll put this on the side. And we will see how that does. Benchmark. These are not particularly good. Our environments are going to be more useful. So let's see if we can figure something out here. I removed the log from the cost. I got this versus, where's it? The heck of a thinking day. Today is thinking day. This one. I want to see how this gets filled in over time, which is why I'm doing this manually. So these are the random samples, right? Boom, 20. These are good samples. Drops a few on the low cost. That's ridiculous. It's interesting that there's such a difference with that log term versus no log term, huh? What does this look like? Maximum cost. It's like $1 billion or something. So it's going to be log x minus log 5, 3, 3 divided by Okay, so we do get 0 to 1 here. And then if so this is, I just want to make sure it's the same shape. It is a log curve. It's like shifted. There we go. Oh no, it's definitely a little bit yeah, it's definitely a bit different here. Interesting. How's Florida? Florida's good. Starting to get a little bit hot, but it's good so far. I have some work to do before I get back to California. I have to do some work on a site for the new hardware and stuff we're doing. But it's good. There's like literally nothing to do other than hang around and exercise and work, which is exactly how I like it. This is 1, 2. So this is not log scaled, right? So this is 100 million. This is very weird because this experiment has given me the opposite result of what I expected, while giving me like higher quality results, order of magnitude, like higher quality results overall, but the qualitatively it's the opposite of what I expected. So I replaced this with a line. That is so confusing. What did I do? Pareto C norm. GPC. That's really weird. I mean, it could just be completely that these things are. I could run it again. It could be that these things are just noisy. Because we got a really good sample early on. I mean, I can't. The thing is, like, maybe I just can't complain about the result because the result is the end is solved. What more do you want? The end is solved. You got a good Pareto curve. What more do you want? Hmm. Yeah, these charts like this is perfect, right? And some of them are going to be a bit noisy. But you have like a fair few like this. A little bit of instability around here, but solved in 20 seconds is solved in 20 seconds. Okay. And what about our breakout one? This is not a good Pareto front for breakout after all, right? Still pushes it to really low cost. Is there something screwy with the log that I'm not understanding? I mean, I guess we'll see. Oh, I mean, I guess, yeah, the log, okay. The other experiment aside, the log on the cost would explain this. It'll try to group everything near the low cost region, if it can't figure out the score at the very least. I guess we'll see how this does. A breakout is a very fiddly task. Very, very fiddly task. Maybe the charts on this. You can just see the amount of noise and the inconsistency in a lot of these curves. There's a lot of inconsistency. How fiddly that is. Well, and literally while I'm looking at it, it just totally crashed the score again. Well, this will have to be experimental. We'll have to just run a bunch of experiments to get this. Yeah. Maybe we can spend a little time thinking about the core algorithm though, right now. If I have any other ideas. Because there's some things I'm still not happy with. But let's do that. That'll be interesting. I'll like do a bunch of diagrams and I'll think through some of the math. And maybe we'll come up with some more stuff as well. I'm gonna use a restroom. I'll be right back and then we'll go do that. Grab a drink as well. Back here. You know, there's something I haven't tried in quite a while. And I don't think it would work based on what I've seen here, but I'm going to do it anyways just to try. Because, you know, what's the harm, right? we're gonna do here. Hey Joseph, today I started learning Prolog at university. Have you seen it used in Prolog? The heck? Isn't that in, yeah, this is... What? They teach that? No idea. Absolutely no idea. That's bizarre. Yeah, no, that's bizarre. That's a new one. I mean, hey, in the US they teach Java, so can it possibly be worse than that? I mean, I guess technically you can use Java at a job that you'll hate but that'll pay you well, so I guess there's that. The algorithm classes were in Java? No, that's unexcusable. That's fucking insane. You literally can't do the algorithm class without having pointers. New language, I find it bizarre. Well, that should not be particularly difficult once you're more experienced, to be honest. Fourth year bachelor's, I don't know. I did my CS degree core my first year, and then I just did research and stuff after that. Have a good one. See ya. Okay, so we do this. The thing that's driving me crazy lately, holy, what the heck? Min score. How's this happen? Wait, what? How? Sweep changes. Min score 0. That's so obnoxious. So let me explain the thing that's been bothering me, right? So the way the algorithm works at the moment, is that if you have a point here and a point here, and this is a terrible line, this is score, this is cost, then in order to evaluate how good a new point is here, what you do is you look at this distance here, and you look at min of these two distances, possibly in log space, and you call this A, and you call this B, and you do A times B. And that's your scoring function. So what this is telling you to do is improve over the nearest Pareto optimal point to your left. So do better than the current best thing, and also try to fill in the curve, right? Try to put points that are far away from existing points. So it does tell you, it tells you to explicitly fill in this cost curve, but this is not quite what we want you to do. We want you to fill in, your goal should be to fill in this cost curve subject to spending the minimum total amount of compute, which is not quite what this thing specifies. But every single effort that I have had in order to attempt to get something to work on that has done this, where it doesn't explore at all because it's like, well, I'm not going to pay the extra cost to run these experiments. So yeah. I'm trying to think if there's any way around that. See, the key thing that's difficult here, right, is that this value B, however you're going to express it, this is the amount of improvement. All right, and then you're going to divide the amount of improvement by the cost. But you really don't have any idea of the scale of this thing or how much you care. So I mean, this thing here, right? Did I kill the server? You see, I mean, this isn't going to really do much. Actually, it did kind of do something interesting here. Yeah, it did this backwards line fill. Okay, hold on, maybe there is something here. Because look, it did this jump, and then it did this like line fill backwards, and then it did this line fill. Okay, so maybe it is smart, maybe it's just outwitting me. I've seen this problem before. This is because you're telling it to improve over the nearest Pareto point, but you are not. The way to improve over the nearest Pareto point, right, is that you go you go like you pick a point that's far out, and then you improve over the nearest freedom point. You just go a little to the left and do it again, and you repeat that. Okay, maybe there's something we can work with here. Okay, I have an idea. Let me figure out how to implement this cleanly. A little bit of code in here. This is quite annoying to get right. It's going to have the same problem. We just do nearest. Does that fix it? Let's try this. Absolute cost difference. We're just going to try some variations on the ideas that I have, while I'm waiting for experiments to run. Maybe I hit on something good, you never know. What? Are you kidding me? Is this a thing? Huh. Bookmarking that. That's something. So what's going on with this cost curve here in the meanwhile? This is literally just improvement over nearest Pareto point divided by cost now. Or I mean, that's much better. It's crazy dense down here. Interesting that the curve almost matches. The full 200. Well, no, 110 was the number. No longer solves in 110. I'm going to give it 200 runs on the suspicion that it probably is more, that it probably does more shorter runs anyways. Trying to think about this in the meantime, though. This would be such like an enticingly simple algorithm if we could get it to work. It's actually not that far off if you think about it from what I previously did. So I was computing both distance to nearest Pareto point, improvement over nearest Pareto point to the left, and distance to nearest point, right? I think that's what I was doing. Yeah. So I've just merged these two to essentially just be improvement over nearest point, right? So then the smart thing to do, right, for improvement over nearest point is you pick two Pareto points, or improvement over nearest Pareto point. So you just pick the point like slightly to the left of middle between these two, right? You're able to still get rewarded if you improve over an existing Pareto point identically. I think it's actually possible this is quite good. Now, I also added in the divide by cost term. So next experiment will be without that. This would be a very simple one. I don't think it's hackable. I don't think it is hackable. We'll see. I'm actually very interested in whatever this is. I recently had to have two cavities, one freaking root canal, one drilled very deep. Still causes annoyances. It's crazy. I mean, this is covering a lot of the space, just not as quickly as you would want it to. We'll see. This is also possibly a best case scenario, because this is a log curve. A lot of the things are not going to be on the log curve. We'll try without the divide by cost as well. It should work without the divide by cost term, come to think of it. How is our other experiment going? Did it die, or is it just slow? No, it's just slow. Does that mean it's doing long runs? Well, I guess these are just the random ones. Alright, so that's some good random data, and now we'll start doing carbs. Or protein, whatever we're going to call it. Been going for a long time. 92. Okay. So here's the full run. Get this X spacing. Very dense right here. I bet if we do it with, let's see if we do it without the divide by cost. I'm curious because I think that this would be very similar to the previous algorithm, just simpler. So this could be a legitimate improvement, and then we'd have to think about why it doesn't work with the divide by cost and how we can fix that. If we need to. Actually, maybe we do real math. We assume that this is a line. For simplicity, we'll assume we have a point at max cost and a point at min cost. And we have a perfect model. I think that this actually has the property we want in the sense that this should approximate, for a straight line, this is approximating a binary search on the transformed score. And this algorithm would be very similar to the previous one as well. Easier to interpret too. But what about this divide by cost thing? Maybe I was wrong about this. So the origin of the divide by cost term in my head is like you're gonna pay cost to run this experiment, right? So you want to maximize information gain per cost. You have this one here with the cost term, this one without it. What about on the percentile task? Time to stretch? Yeah, maybe a little bit. It's not like I don't exercise. I mean, went for a hard run this morning. Did hard deadlifts yesterday. I mean, I get plenty of exercise, believe me. I don't think they've been syncing to Strava lately for some reason. I should check that. But yeah, I'm trying to get back my old strength and cardio from before I was sick. There's good progress. Still waiting on some of the strength equipment. I'm gonna have it all set up at home. I'm gonna have to go to the gym and get sick there. We should use the percentile curve more often. Much more accurate of a representation. Try this. So this curve here isn't bad. I'm really interested to see what this does on the percentile type task. That'll be more informative. The other thing I was thinking about, which would be, we can't test with this, but would go absolutely crazy, would be if we use, during training, we use the entire cost curve to learn from. So instead of treating each experiment as a data point, we take the cost curves, we smooth them, and then we use the whole cost curve as training data. I mean, that's how you could potentially get, you could potentially cut down the number of samples several fold that way. Because then you're getting information over like the whole cost area and you just have to figure out the individual hypers. I think we're gonna end up doing that. It kind of just depends. Like, on one hand, I'd like to just get this research out and done with, but on the other hand, this is literally, in my mind, the most valuable thing I can be doing for reinforcement learning. It's like a niche area that almost nobody bothers to do that has huge, huge potential impact across the whole field. I don't think anybody does it. It's funny. I mean, that's a pretty damn good curve. How high up do we get? We get 9, 9, 9. This is a pretty good curve. Probably avoids some issues. This is worth running. What do we say? Do we just go run this on Pong? Improvement over nearest Pareto point. It's a really snappy, simple algorithm. I think we just run this on Pong and see what it does. Gotta rebuild this. If this does comparably, I mean, this would be a very nice simplification. Should be about the same as well. Token. Okay. So the next thing would be how to improve the data. How to get access to the whole train curves for training the GP. It's a reasonable thing to do, right? I think so. That should let you seed it with just one run as well. It'd be even simpler. Okay. I have to change some stuff around, I would think. That could be heavily worth it, though. Alright, well, let's play with it a little bit. Well, the first thing would be observe. To be from dict or something. Okay. Oh, I think you just have to do Sweep dot suggest args. See, that's a little bit annoying because then you don't know which hypers. Oh no, you can still get it from args. You know, you can still get it from args this way. Like this, I believe. And there's no reason we can't at least run tests while Pong is running here. So we'll go ahead and do that. This will make it easier to use the sweep with whole cost curves. That. Excuse me. That should not have worked. Oh, you put it in the wrong spot, dummy. Okay, args. Yes. Missing hyperparameter end. Okay, there we go. We'll make sure that this still works, and then we can integrate the rest of it. Should still work. And how are we doing on our sweep? We now have 17 trials here that kind of do something. Cool. We have so far similar-ish looking stuff here. Burrito front, 31 seconds for 18 currently. See if this improves. And then we will compare. Use the restroom real quick, and then what we're going to do is we're going to figure out how to get the whole train curves to be utilized for sweeps. I don't know if that's going to do a ton for Pong. We'll see. But, be right back. Okay. This is not seriously going to be different, right? It looks like this could be okay. You just have to confirm that I didn't break anything with doing that. Oh yeah, this is the percentile task. Okay, for the percentile task, those costs are fine. Yeah, 999. Yeah. This is totally good. So we'll just we'll visualize that graph as soon as it's done. It's going to be a little tricky, interesting or tricky, I think, to get the data. Thinking here. Okay, yeah, great. So this is totally a-okay, right? Interesting that we have a couple points at the end here. That's totally fine. In fact, this is pretty damn near perfect. And this is actually the type of curve we should probably optimize more for, because a lot of them look like this. What I'm thinking here is that what you get back from the environment, your estimates have to be smooth. And we adjust logging, we adjust the report interval, not based on smoothness, we adjust it based on having the local dashboard. All right. Let me look at something here if I do this. Evaluate data. Okay, so here we return the logs, right? We get uptime. Okay. Oh, this is not going to return anything, right? No environment stats yet. We're kind of just tacking on this thing at the moment. I'm obviously going to clean all this up nicely for the users. A lot of good data here. Okay, that's some good data, right? That's some very nice data. Very chill stream today. Thanks. Yeah, well, we're kind of just fiddling with algorithms. This is going to be really, really cool when it works, though. Is there an easy way to interpolate? Oops, wrong type of window. Just do it here. Cool. Do something like this. Yeah, we're just gonna throw a linear interp on the score data, I'd say. Go up here for now. Downsample to 10 points. Making a little bit of a mess here, but I think it's worth doing this just to get something to test. Okay, so 4. Something like this. How's our palm sweep going while I've been working on this? Should be something by now, right? And this is 65. What do we have here? Okay, breakout's kind of done something. Oh yeah. $19 and 23 seconds. Yeah, it'll definitely find some good stuff here. It's looking very similar to before. We'd have to confirm it's exactly the same or not, but it looks very similar to before, quite reasonable. So I'm not going to worry if we accidentally kill this in the process of running some new experiments. I think this will be pretty darn good. these resamples are really doing anything. I literally just do this, right? Yeah, I think we rerun for this. This will be a very nice comparison. This is definitely going to be interesting. I'll kill this if this doesn't do anything. Okay. I don't know if this has been done before, honestly. I think any sort of learning rate schedule probably breaks this unless you handle that. But pretty darn good overall. I mean, maybe not even, come to think of it now. It depends how you do the schedule, how you would do the schedule, I guess. So this is now getting 10 times as much data for training the Gaussian processes that decide the sweep. We'll see whether that's useful or not. I'll be right back. I'll use the restroom. We'll see how this sweep goes. We'll fix it if not. And I forgot to unmute my mic. Whoops. Still though. I don't know if this is going to be massively better. We will see. The place where I think that this could be really important is for much longer experiments, where you really need to get a lot of data out of each experiment. having a subsample every 10 million steps or every certain number of steps could really help. It's interesting that it's getting so many bad points, though. Well, I did kind of ask it to bootstrap off of 1 point instead of doing the random trials. So if I'd run the original, it would have been 1, 2, 3. These would have all just been random. So we'll see how quickly it learns from here. Well, there's something. Is it going to crash back down? There we go. So, I mean, it's not completely failed. It just took it a little bit. Didn't like destabilize or something. I mean, the trade-off is you don't have to do random samples. Technically, you could. You could still do that, but well, this could be better. It is very obnoxious to have to do 10 random search trials every single time you do an experiment as well. I think this will be better. What'll be interesting to see is how this does, a little bit later on. If this can like uncover the full curve in 50 trials instead of 200 or something like that, or 50 instead of 100 even would be awesome. I'm getting the full cost curve information. So two very important modifications to the algorithm today. The first mostly keeps it the same but simplifies the math quite a bit, and the explanation of it, it's just improvement over the nearest Pareto point. That's the whole algorithm. It's just, maximum improvement over nearest Pareto point. You can see how difficult these curves are to predict. So, I mean, given that I figured that given it's going to be a very noisy estimate anyways, you'd rather have a lot of noisy data than a little bit of noisy data, since there's really no way to make it not be a noisy estimate, because there's seed to seed variance in RL, right? Like you run the same experiment multiple times, you don't get the same result all the time. So given that, instead of just trying to make that like that one data point really, really accurate and then depend a lot on it, it's better to have a whole bunch of noisy data points. They're going to be noisy anyways. This is something. Where's her front? So we'll see how well this does. It's kind of all the stuff I wanted to do. What time is it? Oh, it's 5:40 already. Doesn't make sense to start something else. Let's take a quick look at the Discord and see if I've missed anything in here. In the meanwhile, I just was seeing, let's see, this thing, the same improvement. Huh. You know, this x-axis is very painful here. Why is this not a billion? Oh, I thought this was from, my bad, dude. I thought that this was from a paper. I thought this was from an existing paper. If you hadn't said that, nobody would have known. But, okay. From the syllabus paper. Very nice. That's cool. And domain randomization is the baseline. I got static working. Good job, Spencer. You can go ahead and PR that. You can show it. I don't care. It's fine. Which is SFL versus LP? Because we're currently doing the Minecraft like curriculum learning progress thing for Puffer, and it would be good to know if that's reasonable. We kind of want the best thing that doesn't involve an LLM to start with. Be zero success rate. Curriculum learning. 1 sec, I'll find. Yeah, it would be good to know because we are doing curriculum stuff on Puffer ends at the moment. We're also attempting to do massively soda hyperparameter tuning. That's where the method is from. Let's see. Okay, this is a different one. I think, was this the one that was just presented at NeurIPS? Yeah, learning progress one. I think I was suspicious. No, I forget if it was this one I was suspicious of. Might have been. I think I saw these two M's and I was like, yeah, okay, you know, this is not a real task. That's LP in the plot. Okay, so this is SFL. Oh, wait a second. I think I remember this one. Collect learnable. Oh, I thought that this one was really freaking stupid. This one's massively more compute expensive, isn't it? Well, no, I think it's massively compute expensive, right? LP doesn't involve this extra step. They're not training on these levels. You train on all the levels with the curriculum one. Every once in a while. You should train on all the levels that you're using. Like you should train on all of these. Yeah, you shouldn't do that. You should just train on everything, I would assume. Top K levels. Learnability, and then do they give this learnability thing? How is this even different then? Yeah, that would be useful because we're doing some stuff with Aaron on some puffer M's. Yeah, no, of course we can chat whenever. I'm free. Like, I'm pretty much free whenever. I've also been working on my own algorithms lately in hyperparam tuning. That'll be pretty cool. This is their SFL. All right, cool. I mean, I can go do that real quick before dinner. Let me just end stream here. Randomly, a lot of people tune in whenever I end up chatting this, but so yeah, for folks on Twitch and YouTube, I don't care if we talk on stream. Cool, then we can just do that. That's even easier. I'll hop in the Discord. Chat about learning progress. It's more fun when these are on stream anyways.
Hey, what's up, man?
Hey, how's it going?
Oh, I have to mute your stream. There we go.
Yeah. We're gonna chat about this, and I'm going to dinner, and then do you know what today is?
No.
You play
I don't.
games, don't you?
Yeah.
It's the new Overwatch season.
Oh, I forgot about. Are they releasing the patch today?
I think so, yeah.
Oh, God save you.
Yeah, I know.
I've been playing Marvel Rivals.
Oh, geez, that's even worse. All right,
I think they're both equally awful.
this is fair.
I miss when I played a respectable game like Valorant.
I don't have Windows installed because that's more addictive.
Yeah, that's a good
Yeah.
call.
I
But yeah,
also, I
so
think we're very close to having hyperparam tuning for RL solved.
I'm excited for that. I've actually spent the past, I think, 2-3 weeks just doing hyperparameter tuning for the syllabus paper. Not because I give a shit, because I I don't need to tune most of these methods. It does almost nothing, but reviewers will complain if I don't hyperparameter tune everything.
Oh,
So I've been
it'll do
running
a
these
lot
massive sweeps.
when you actually throw our hyperparam algs on. Are you just using random?
Well, okay, the problem is that the methods don't work on
Yeah.
2 of the environments that I'm tuning them on, but it's like you can't just say they don't work if you don't tune them. So I'm tuning
Yeah.
them and they look exactly the same. It's just pissing me off.
Yeah, well, we've got the current one sentence version of the algorithm is optimal improvement over nearest Pareto point.
I mean, that sounds like a lot of good things.
Yeah. And I just modified it. I don't think any algorithm has done this before that I've seen. We're now
Mhm.
using the whole learning curve as data for training the models used by the hyperparameter tuning algorithm instead of just like the final point.
Oh, that's awesome.
Yeah, so we'll see how that does. That'll take some tuning to get right. You gotta tune
It
the
sounds
tuner.
cool.
Yeah, it's been a lot of work, but it's been good. Anyway, so
Oh, I
yeah, we
bet.
are doing some curriculum learning stuff actually, like formally with Puffer now. Um,
Sweet.
we have the maze env obviously that I made, so it's just a million step per second or more maze environment
Hmm.
that's like procedurally generatable, different levels. It's good for exploration. It's good for curriculum learning, right?
Yeah.
So we have that. And the first method that I thought to try was the Minecraft one because it seemed like the simplest one that was reasonable and that had like a
Yeah.
really cool result come out of it.
Well, that is implemented and baselined in syllabus now. Perfectly matches the original implementation. So, if you want to do that, it
Damn it, let
works.
me just message that to Aaron.
Um, Aaron Darna.
Yeah.
Oh, he's working on that with you.
Oh
Nice.
yeah.
Well, I'm down to get in on this then. That sounds like a fun team up.
Uh, yeah. So
Yeah.
the thing that happened here, by the way, which is why I didn't think of you initially for this thing,
Hmm.
was that the initial research discussion of topics were in a somewhat different area.
Sure.
Yeah, so that's why that happened. Otherwise, because I have you on my list of people for these.
Well, yeah. I mean, if you wanted to do that curriculum, it's literally implemented in syllabus. I have it
We'll go
working on
look
like
at it.
4 different environments and 4 different RL libraries, so it's pretty easy to add to new stuff now.
Awesome. We will have
Um,
to port it to work with Puffer, I assume, because of our high performance M format.
You will, but it already works with MooLib and a version of PufferLib,
Okay.
like 0.7 or
It doesn't
something,
even have
so
to
it
go through
shouldn't be that hard.
multiprocessing either initially.
But yeah, if you're just running on a single core, then we
RMs
could
run
cut out a lot
millions
of the
per core,
complicated stuff.
right?
Yeah, we can cut out most of the complicated stuff then.
Yeah. So that's the initial goal for that. We're also doing exploration work. There's Aaron in the call. I'm still on stream, Aaron, but we can
Yeah.
chat the research side, not the business stuff. Um,
Hey, how's it going?
Hello.
yeah.
How's
I'll put
Uh,
life?
so Ryan apparently has this and some other algorithms in syllabus. I still like that you've reproduced those curves. Those curves are useful because Ryan, I assume you didn't bother with the curves in the paper, like the theoretical ones.
Oh no, I did that a long time ago. I haven't checked them in a while, but
Okay.
I mean, I have like the full training curves reproduced. Actually, I can just
Yeah,
let
the
me send that to
training
you now.
curves. I mean, they have like a bunch of these like theoretical sampling curves.
Yeah, let me just send
Okay.
this. Um,
Whatever. These
here.
things research
I'll
ends up
put
being roundabout anyways. This is fine.
I'll put one in. I'll put them in chat.
Yeah. We're making progress on the hyperparam tuning stuff as well, Aaron. It's in dev now at the moment.
Nice.
I have like literal thousands of experiments on this.
where do I send these development?
All right, Ryan. I just put them in chat. The top one is me, and the bottom one is the paper.
Mhm.
Uh, sorry, which chat?
You press the open chat button on the general chat that we're in. It'll open a place
Holy
where you can
crap!
drop
I've
stuff.
never used that feature in my life.
Yeah.
Very nice. Yeah, I think I have the code for that, but I haven't run it in a long time. But I have these curves from training on Crafter.
Gotcha.
Okay, but PR to merge at the same time. Spencer did. Spencer just added a crazy good
Oh,
environment for curriculum learning, by the way.
you you did get Omni going finally.
Yeah, I got Omni going, although I just copied the implementation from Jenny's code, which
Jenny.
is not like. I have to say the implementations of both those algorithms are like a lot different than the picture you get from the paper. They front load all the LLM calls at the start, so they just like cache them all into a big dictionary and then they just reference that. So like the implementation in syllabus just assumes you've done that work and put the dictionary together, and it just calls it the same way that her code calls it. But
Wait,
it's
how does that even make sense? The whole point of this was they're constantly calling the foundation model and being like, "Hi, what should I do now? What should I do now?"
yeah. So rather than that, they have this dictionary that basically says, given one particular task is like, given you're proficient at one particular task, which of the remaining task space is interesting. So it's like an n by n dictionary for every task. So every task has tasks that are interesting given proficiency at this particular task. And you just have a full dictionary over the
Interesting.
entire task space, and you just reference that throughout training.
That
And you
is
use
not
those
how I
as
would have done it.
yeah, it's not online, but it makes sense implementation wise because it'd be really annoying
Yeah,
to call an LM in a loop. Um,
for sure.
but yeah, that's how it was done in her code. At least for the crafter code, I think the like AI Thor and baby AI experiments are newer. I'm pretty sure I got the code base and looked at it at some point. I'm pretty sure she does it the same way there, but it's
I would
possibly like
expect so.
yeah, that's what I'm thinking. Um, but yeah, that is that's how that one works. And then the learning progress curriculum, I guess you've probably have you implemented the whole curriculum or just like the individual functions?
So far, the individual functions. I was starting with the more full implementation stuff tonight.
Yeah. So the um the learning progress curriculum I was mentioning to Joseph does like this huge evaluation loop over the entire task space every like 25 batches. So like every 25 algorithm updates, it just evaluates every single task in the task space for a certain number of episodes and then um, uses that to calculate learning progress, and it doesn't do anything online. So it's not getting anything from the training data to calculate learning progress.
Where did you catch that? Because I didn't catch that when I read through it.
I'm telling you, it's not obvious from the papers at all. It's only in the code. Um,
I didn't think they had
and
code.
I've
Yeah, I didn't
for
remember
Omni.
seeing code.
Oh, it's in the Omni paper. So Omni is like fully based on this curriculum.
Yeah,
So it literally uses
yeah,
the exact same curriculum and then modifies it with the LLM calls. So
Hmm.
she has an
yeah,
implementation of the LP curriculum in her code base.
I didn't realize
yeah.
that.
But
Maybe
that
it was a
was
follow up. I didn't realize that was a direct follow up.
yeah, it's a
It,
direct follow up.
yeah.
Cool. So we can just have the non LLM version as a start, and we have like ultra fast, pretty good curriculum.
Yeah. So sorry, what were you saying, Aaron?
Basically, um, what was I saying?
You said, but might have been an interjection.
I
I
don't
don't know.
remember anymore.
Okay. Um, but yeah, I have those implemented in syllabus. Although, if you can probably make it run faster by implementing it directly. Um, but you still have that huge evaluation loop. Um, the problem is you
Oh
can't
yeah,
do the evaluations online because you won't
I was
be
gonna say I
evaluated.
was thinking just do it online. Like do like you stay with your current sampling method until you have data covering all of the tasks. And then once you have data covering all of the tasks, use all that data to update your sampling distribution.
You could do that, but you'd have to make sure that there's like some probability on everything, and I don't think. Um, I'm trying to remember. I think that
Jenny's stuff
the
has Jenny's stuff for the LP has stuff set up where it can work if you don't put full probability mass on something.
yeah, I think it can work with a more like smoothed out distribution. The version they use in Omni has this normalization, which it like
Yeah.
subtracts the random agent
Yeah.
task success rate.
Yep.
So if you use that, then there will be a lot of tasks with um, no probability on them. But if you take that away, it performs a little worse, but you'll at least sample every task occasionally. Um,
Well, worse than that, it just samples random vector from NumPy rand.
wait for what?
It does so that random task success is
Yeah,
just sampled from NumPy.
it.
Wait, what?
I'm pretty sure it actually evaluates. No, no, it evaluates the first like the agent that you start with, it uses that as the initial baseline.
Maybe I'm missed something, but I was pretty sure I remembered.
I feel like I remember seeing what you're talking about, but I think it was related to something else, although code bases are hard. I'm forgetting some of the details. Um, but yeah, another thing, there's this other method, sampling for learnability, which I tried on Crafter, and it just works better.
Uh.
It's like, here, let me send that plot.
That's one data point, of course.
True,
Is it
but
just
in
a
their
different
paper, it works
function?
better. It's literally the exact same algorithm, but with a different, like, rather than doing that whole complicated learning progress, it's just task success times 1 minus task success. It's like they replaced all the learning progress stuff with like a dead simple function.
So we'll try both,
Oh,
right? We have lots of. Did you see Spencer's new environment? Because that's another one we can try this on. It's pretty nice.
So yeah, sampling for learnability works well in Crafter. And I also found out that the algorithm that Omni uses in Crafter is just like you can replace it with like 10 lines of code just because I think the baby AI and AI Thor experiments are more advanced and like the LM is actually doing something clever, but for Crafter it's just doing something really dumb. It's just taking out all the duplicate tasks. Um, so you can even implement that as an option if you wanted to.
We're not ever doing any experiments on Crafter. We can do them on CraftX though.
That's fair.
Actually, I owe Jacob some compatibility patches for Puffer anyways. So if we want to do that, that's directly in scope.
Sorry, for which environment?
For just Jacob stuff in general, we started 2 new formal lab collaborations with at NeurIPS. You know, we just discussions with the professors. One with Kathy Wu's group, one with Jacob Forster's group.
Mhm.
And then I immediately got near lethal pneumonia, and that's
Right.
kind of thrown everything off. Because I had to get the company and the business side back on track. But yeah, we'll be resuming a lot of that stuff shortly.
Gotcha.
I'm also slowly getting my fitness back.
That's also good. But yeah, I mean, if you want to talk about how to implement the LP stuff, or if you want to try a sampling for learnability, I'm happy to go over some of that stuff. Or we
That's
could
going
just
to be
use
great.
syllabus.
Well, the thing is that we have million step per second environments. Tricky thing.
I think if you don't use multiprocessing, then I don't think syllabus will cost you anything. I mean, like the curricula themselves are slow, so like you have to.
Why are the curricula
You know,
slow?
well, for one, learning progress does a massive evaluations like sweep that's almost as long as the actual training.
If we do it
So
online.
I was about to say, just do it online then.
I'm still worried about doing it online because your evaluation quality for most of the seeds is going to be like terrible.
Okay, but like, okay, Ryan, then we can do evals at 2 million steps per second.
Well then yeah, then the curriculum won't slow you down that much. If
Well, because
if your
like
evals are
training is a
fast.
million, training itself is like a million, so it'll still slow stuff down a fair bit. But like, we can do all sorts of things because we have fast speed.
Sure. Well, the curriculum itself, like if you really want to do it fast, it's just like 10 lines of Python code for SFL that you can just call directly from your main PufferLib code. Like if you're willing to do a little bit of integration work, you can make it a lot
We were
faster.
going to stick it into the environment code because it's a vectorized environment in C.
I guess you could stick it into the environment if you don't do multiprocessing and you
Yep.
don't have more than one environment. If you're literally running a single environment, then yeah, you can do
no,
that.
we have like thousands of them, but like they're done in a loop in C.
They do need to be synchronized to some degree.
No, they're run serially in a loop and see.
Well, no. The curriculum should be synchronized. I mean,
Yeah, we can do that because it's like they all have the same memory for stuff for like learning progress and whatnot. Like you
yeah,
don't have, they're not on separate processes where it's difficult to sync stats and stuff.
gotcha. Okay.
It's like very transparent and easy. Have you heard the good word of
Yeah.
C?
That should be fine.
Okay, this took a while to get off the ground, but currently this is 19 score in 21 seconds with the new method. Though the previous best, I think we had 20 score in 18 seconds. We are currently, but we are solving Pong now in sub 20 seconds.
Very nice. And so you said you want to do this over a maze environment?
Yeah, the maze environment that I wrote. I wrote like a procedural gen with somewhat configurable difficulty, maze environment, configurable sizes, can be reset to different sizes dynamically. Like observations all work out just perfectly and stuff with that. It's like supports continuous and discrete movement as well in the maze. Yeah.
Okay. So I assume that you want to. This will just be over like level seeds,
Mm-hmm.
the curriculum.
Well, but you could do level size as well.
Yeah.
Level size too. That's true.
And there's a
Um,
difficulty parameter in the maze gen.
what does that control?
So the way I was thinking to start it off was just doing it over that difficulty parameter.
Well, the only thing is the
Okay.
difficulty parameter is not entirely intuitive because I don't know if 0 or 1, like 0 might not be the easiest and 1 might not be the hardest. Because it's technically like an interpolation between two different algorithms that produce different types of mazes.
Gotcha.
Might be a little optimistic, but ideally the curriculum can figure it out.
It should.
Yeah.
Just throw everything into the curriculum algorithm. I mean, I think that just with simple domain randomization, I got it already to solve like decently sized mazes. Like I had a policy that was doing pretty reasonably,
Oh yeah. Demand randomization is great. It
especially when you
works pretty
train for a
well.
billion steps.
But literally, if you want to try SFL, that's the algorithm right there. It's
Yeah.
it's
And you can
about as
just go
simple as
ahead
it
and look
gets.
at that from syllabus then, Aaron.
You want to try what?
You can go look at that from syllabus and see
Oh
if
yeah.
that works in Puffer for the mazes.
Yeah, you can also just
What
use
was
syllabus.
SFL?
That's sampling for learnability. Let me send the paper
Okay.
again.
Yes.
Gotcha. The success rate version.
Yeah.
Yeah, I was talking with Michael at NeurIPS about that one, and I definitely think that that makes a lot of sense if you're fine sort of alternating between getting that data, doing some training, getting that data, doing some training.
If you're gonna do them both online anyways, is there a difference?
The difference is just the metric then. But again, I'm not sure that these things work online. I did want to try it, to be fair. I was planning on implementing it myself, so this
If
is
we have giant batch
a fun
sizes.
conversation. Yeah. The only issue I would think is that if you get really bad evaluation quality for some of the tasks, then you won't realize. Like, if a task has a 10% success rate and you evaluate it like 4 times, you might just get a 0. And so you won't identify tasks that are like becoming learnable until they're already like pretty close to solved or like decently learned, which is kind of counterproductive. I don't know.
Yeah,
I might be
so
wrong
it'll
about that
depend
though.
how fast stuff moves as well. I mean, if we're looking at like harder environments that actually you're gonna take a while.
Oh,
Right?
actually, now that I think about it, so what I sent you is sort of my like lazy version of SFL. The actual implementation, which I do also have, samples. It basically takes 2 uniform distributions. So they find the top like K most learnable seeds, and they uniformly sample from that 50% of the time, and then they uniformly sample from the entire task distribution 50% of the time. So if you use it the way that it's originally implemented, where you have like at least some sampling over all the tasks, then you'll always have like some online data for all of them, and it might actually work pretty well online.
Oh, I see what you mean by that. Yeah, okay. It doesn't have to be 50%. We could tune that as well with the tuning algorithm.
Yeah. I've been tuning it for my environments, and I found like 0.75 tends to work pretty well, but you could do whatever you want with it. And you could probably do it smarter, like rather than making it literally just two uniform distributions, you can like mix them more cleverly. I
Yeah.
think there's distributions for doing that.
Gotcha. Can you give me a pointer to the syllabus implementation?
Sure. It might be on a testing branch right now. I'm trying to write the paper right now, so it'll be merged in a week and a half. But for now,
Oh, are you sending it to RLC?
that is the plan.
I've been thinking
Me
about if I want
too.
to take a day to write up Puffer 2.0 for RLC. Or if they can piss off, I don't know.
I think it's worth a shot.
It would
I
be
don't know.
good for like there are probably some industry people there to talk with. But like,
Yeah.
oh god. The last conference nearly killed me, alright? It's kind of put a damper in things.
It quite literally did nearly kill you.
No, like seriously. Do you know how much it sucks getting your cardio fitness back? It's really hard work.
Synth-Link.
Yeah, that's why I don't do as much of that as I should.
Like my average training run gets to 185 heart rate now.
I also don't exercise because wouldn't it be a shame if I lost all that work? That's totally the reason.
It's good to be in shape. The new puffer facility is it's straight up a warehouse with a bunch of servers and a gym.
Everything you need.
It's literally that's straight up what it's gonna be. It's gonna be great.
But I don't remember if I got this thought out or not. But if you want, I think syllabus should still be easier to use than implementing it from scratch. So you can like test stuff with syllabus and then implement it if you want to do actual sweeps. But you could just like run a single trial run. It'll probably be slow, but I don't think it should be horrible.
Yeah, the question is just like Puffer, we have our own native end format now that we'd have to fiddle with.
I was gonna say,
Yeah,
I think that's the main thing to mess with right now.
I mean, it doesn't go through multi-processing, right, for the native like single process ones, but it's basically our default format is a backend. That's all.
Yeah, syllabus doesn't care what your vecenv is.
Mhm.
It just you just drop a single wrapper on the environment and it works.
Ooh.
I mean, presumably you're chucking a lot of that stuff through infos. Is how you're sending it around then?
No, it creates like a separate multi-processing pipe, but if we're not multi-processing, it'll just be like a standard pipe. So it should be. I think that runs faster if
Oh
they're in the
yeah,
same process.
we
It basically just creates an individual pipe.
not for like another several months, but like when eventually people start migrating to the newer Python versions, we're probably going to kill pipes completely from the implementation because it'll be on threads, and then we'll have even more speed. Though for our native
Yeah,
M's, it
that'll be
literally
nice.
doesn't matter because we're so fast, but it'll
Yeah.
be good otherwise.
I can't wait for that update because syllabus
Got it.
is
You're
just gonna
saying for
magically get
once.
faster.
Once Python has threading, that works.
Yeah.
So you're going once for the no-gil version comes out.
Not when it comes out, when it's been around for long enough that people should have updated to it by now. Because it's a
Gotcha.
breaking change. That's like a major breaking
I was
change.
when is that supposed to be?
I don't know. It's not a huge deal because, like I said, like our ends are so fast that we do not care. And
Yeah, I haven't heard
Yeah.
any updated timeline for it, but I'm looking forward to it whenever they magically solve that problem.
I mean, I've kind of realized that in order for Puffer to be attractive to companies, right, one, I have to do some business side stuff. But then the other thing is just we have to really lead the charge on like RL progress. And the way to do that is not by being constrained by the things that everyone else is stuck on. Like everything needs to be fast by default, period. That's it. So like it doesn't make sense for us to go like spending a bunch of time on Atari baselines or something like that anymore.
Sure.
huge ways to compute. Oh, I did do one silly thing last night. We have multi-GPU in Puffer now. It's experimental, but it works. And it skips like linear scaling. I tested on 4 4090s. And those 4090s were like undervolted or something. So the single GPU speed was 200K. And then it went to close to 800K for 4 of them. So that's just
Well
how
done.
in-depth is a thing you can do. Probably eventually at some point we'll like get a tiny box or two for the cluster, but not a ton of them.
Mhm.
Like it's the single GPU stuff is still pretty darn good.
Yeah, I just don't. I don't know. I don't see the benefit of multi-GPU stuff when most of the models I'm working with anyways are like too small for
No, it's
even like
mostly for industry
10
people.
series GPUs.
It's
Yeah.
mostly for because I've had multiple industry people ask me if we had this, so I finally just like said, okay, I'll add it. And then I immediately went and messaged the industry people like, hey, we got this now.
Mhm.
Right.
But if you want to try these methods, I promise it'll be easy with syllabus.
All right.
I can help set it up, but I've made this stuff work with 4 different libraries at this point, and worked out
And
a lot
all
of
of them are
the
worse than PufferLib.
dude. If I can make this work with PufferLib 0.72 in neural MO,
Okay, yeah,
I think I can
that
make it
was
work with the
pretty.
upgraded version.
Look, okay, this was. It took a lot of work to get stuff to this place where it is now. Like, neural MMO and the multiprocessing stuff in 07 was state of the art for the time by a mile already. Just because
Oh
we're
yeah, it
100
was.
miles ahead now doesn't mean it wasn't already ahead then.
Yeah, it was still the best option for neural MO too.
It sucked,
It's just
I know.
I think it's got to have like 4 or 5 times less development time in it than the current PufferLib version. I can't remember how long ago it was.
Yeah, because I've been full time on this since the spring, like last spring. So yeah, we're coming
Yeah,
up
and
on
the
a year.
version we were using was like it was like May of last year, right? That's when we were running all
Yeah.
this stuff. Yeah, so I mean, I'm excited to see how much better it is.
It should be a lot
There
better.
are some typos in the old the old PufferLib code too.
Oh yeah.
But yeah, I think if it works for that, it should be easy enough to add to
Mhm.
whatever you're working with now.
Yeah, the main thing, honestly, the biggest thing in the last 6 months has been all the environments in PufferLib.
Yeah.
I mean, that's been the main focus. And then in the last like couple of months, the new algorithm side stuff has been hyperparameter sweeps, a few academic collabs, a few other things around this. But yeah, we have a few other things lined up as well for pretty soon.
Sweet.
We're gonna have to see with the 5090 availability. That's gonna be the big question.
True. Although I'm still on the team of using slightly older GPUs for cost efficiency.
The thing is, they're not really
My
cost
guess.
efficient because it's still hard to buy 4090s in bulk at the moment, and you're gonna pay between 5 and 6 grand for a box anyways with a good CPU and stuff in it. So the
That's true.
GPU is only gonna be like between half and a third of the price anyways. So if you can save, let's say you save 20% the price of the box, and you cut your GPU speed in half, that's not really great. Because we
Fair.
are GPU bound now with our M's. So yeah, the new boxes that we're looking at are 9950Xs, 5090s, 128 gigs DDR5, nice drive, nice fans, nice cooling and all. Should be nice and stable. We've kind of dialed
Sounds
in the
good.
setup. We're getting the new Puffer Box 4 back in a couple of days as well, so hopefully that'll be one more
Nice.
box for somebody to play with. Probably Kyung will get that one for the work we're doing at the moment. We'll see.
I think I've resolved all the issues with access to my cluster for now, so I have a couple more months of GPUs.
Jeez.
I don't know if I probably didn't tell this to you, Aaron, but our cluster went like literally got hacked. So our entire
You mentioned it
computer
last time
cluster-
we talked.
Okay, yeah. It was down for
Disastrous.
like 2-3 weeks. And then my advisor is leaving UMD, so he's no longer allowed to sponsor accounts. So my account was going to get shut down on top of that.
Jeez.
I've finally
Yes.
resolved all these issues.
Just gotta get Puffer compute.
Yeah. Well,
I
look, I'd rather use UMD's infinite store of like 1080 GPUs that no one uses than
Yeah.
waste yours.
let me see if I have the I thought I recorded this photo. I guess he didn't send it to me. It's weird. I don't know where it would be then. Me? Damn it. I have a cool photo somewhere, but I don't know where it went of like the wiring and stuff in the new facility.
Mhm.
It's gonna be nice. It'll take a little time still. And then the annoying thing is like 5090s, apparently there's an issue where the cables are melting on them. So I'm gonna wait until that gets
I saw
resolved
that
before I
online.
order.
Well, that's great.
Yeah, it's like I'm not gonna order $250,000 worth of hardware, right? And have the cables melt.
Not ideal.
That'd be terrible. Oh, look at that. So interestingly, this one took a little longer to get started. We're gonna see where it ends up, because after 85 runs, it's still not getting the 20 scores, is the weird thing at the low cost. We'll let it go. We'll let it keep going for a bit though. This should be so much better than before, but the training curves don't seem to be like noticeably helping it, which is odd. Oh yeah, Aaron, I did a thing where the hyperparameter sweep uses the entire training curves to train its models instead of just the final point.
Interesting.
I also simplified it. I realized there was a way to simplify the math tremendously. So it's literally now it's just the algorithm is largest expect. It is just expected improvement over nearest Pareto point. That's it.
Wow, you can simplify the math in an RL algorithm? That's surprising.
No, you can't do that. It's not allowed.
Well, okay, to be fair, the original implementation of this, I think you've both seen this at this point. The original carb was like 2,000 lines. This is the math right here for the new one. It's pretty much just this screen.
Mhm.
So like, yeah, there's a little that'll get deleted, but like there's this final thing just for at the end. So that's the whole thing. The whole file is less than 500 lines when you cut out all the comments and stuff. It has 3 different algorithms implemented, and they're really easy to use. Protein.
Well done.
Working name protein.
I do have to get back to writing, but
Best of luck, Brian. And I'm gonna go get
let me
dinner in a
know.
second.
Let me know about this curriculum learning project if you want like help implementing
Let's
stuff or just to talk about
let's
it.
chat this weekend, Ryan.
Sure.
Whenever you need a break from writing.
Okay, that works for me. I have literally spent the past like I don't know, few months, maybe a year implementing these curricula, so I can definitely help out with this. Speed it
May
up.
I suggest the approach I've taken to all the papers that have gotten accepted is to be as stupid as possible and write them in like a day and a half. The papers I spend time on do not get accepted.
My problem is that syllabus is such a freaking weird library, and it's designed in like the dumbest way possible because it has to be to work the way I want it to. So explaining it it's so hard.
Yeah, they don't know or care about those details, so you just don't put them in.
But if you don't care about those details, the library just sounds like it does nothing. It's like the whole point is making like the pitch is that you could apply curriculum learning to literally any RL library code base. Like any training code you have, you throw syllabus on it and it'll add curriculum learning in like a couple lines of code, which makes no fucking sense. And it doesn't make sense why that's hard, or if you understand why it's hard, it doesn't make sense how it's possible. So explaining it is driving me insane.
Yeah. This is fun. Academic writing is such a joy. It is such a privilege to be able to spend the time in your 20s doing this.
I've spent the last
Bitch, I'm
week
in my
organizing.
30s.
Yeah, it's all right though. Like you're set. You're fine.
Yeah. I've literally spent this week organizing my defense, which has taken so many hours,
Really?
and like running shitty hyperparameter sweeps for syllabus. It's just been the most draining work possible.
That's the one thing I actually spent time on was my defense. I spent like no time on my thesis. I think I spent like a total of maybe 4 or 5 days on my thesis.
No, I'm not talking about the defense. I'm talking about scheduling the
yeah.
defense. Like, I haven't touched the presentation.
Yeah.
Oh,
Well, the presentation took, I think that was probably a solid 3 weeks worth of work.
Yeah. Anyways, okay, I do have to go back to
See you,
writing.
Ryan.
I'll message you, Aaron.
sounds good.
See ya.
And yeah, this is what I've been doing here. We're gonna wait on these experiments, and hopefully I will ship you this stuff so you can play with it. Who else has joined this thing?
Hey,
Hey, how's it going?
we
Hey, how's it going?
kind of great. I think we talked on X briefly, but like super briefly, some time ago.
Probably I can't see the Discord name because I have the streamer mode thing enabled because I'm on stream still.
Oh, you're on stream.
Yeah, you're free to chat. I just like I let people know you're on the stream. I mean, there are a total of 5 people on it, so whatever.
Okay.
Oh, I'm famous.
Yeah, I stream a lot of my dev by default. It makes it really easy for people to just drop in to the chat and like get help on Puffer, get stuff. Like every single week, I get like several users like asking me stuff on how to make Puffer work or how to do a thing. So it's pretty convenient for that.
Yeah, I'm guilty of that. I've done that a few times for you.
I mean, that's why it's there. It's meant to Puffer's meant to come with the best support out there.
It does.
I hope so. This is all I'm doing with my time these days.
Anyway, are you streaming only on X?
Yeah, I'm on X, Twitch, and YouTube.
Oh, okay. On YouTube as well.
Mm-hmm.
Do you have some kind of counter to like calculate total amount of viewers?
I can see YouTube and Twitch, but X only gives you total views. It doesn't show you like current concurrent viewers.
That sucks.
Yeah, so you can't actually tell with X. You can tell with the other two.
Mm-hmm. Okay. But yeah, like my nickname is Tarafo. Like a couple of months ago, I had a bit,
Yeah, good to chat with you.
and I think we are in same chat on X, basically.
Same chat. Is it? Oh, one of the group chats.
Yes, same group chat.
Is it the Henson one or the ML and like whatever chat?
ML.
Yeah, okay. I post RL stuff in there occasionally, and then it's all language model people, so they just proceed to ignore it.
Oh, I mean, I am language model people, so I'm guilty of that.
Well, there are cool things happening over in RL land, so. Yeah.
I know, but it's so it's scary.
I mean, it's kind of
scary.
moving.
Not anymore,
It's-
not with Buffer.
Okay, I probably should try it, but like that's what we talked about like in October, and
Mhm.
I said that I should try it, and I still haven't. And
We
it's February
have-
now.
if you just look on puffer.ai, we have a dozen reinforcement learning M's that run at over 1 million steps per second on a single CPU core and train at hundreds of thousands to 1 million steps per second as well. One GPU.
By the way, do you use some kind of ECS or not?
Not exactly. Like technically, the M's are all written in C, and they're structs in contiguous memory. And an ECS works by looping over structs in contiguous memory. So like kind of, but we don't have like a full ECS system where we're adding components. We're just like kind of doing what an ECS would do.
Okay. You have similarly designed, like ECS
Similarly
Lite.
designed, sure. Yeah.
ECS Lite, probably.
Yeah, it's done per environment, so it's a bit more manual, but at the same time there's no ECS to like have to go through and understand. It's like any of our environments, we have some of the most sophisticated RL environments, but a first-year undergrad can understand our code after they've taken their first systems class. That is the goal, and that's how it is.
Yeah. Oh.
Because like, oh yeah, it's scary. You have 20,000 lines of C, but then you actually read the C, and it's like, this is an if statement. This is a for loop. These are the things that we use. That is all.
I know. I just have like some kind of I don't know stain to see. I don't like it.
Hey, you've been lied to. It's great. It's the
No,
easiest
no.
programming has ever been.
No, I don't. Like I haven't been lied to. Like I interact with C like constantly, and I
I
don't
see.
like
Do you interact with C or C++ constantly?
both.
Okay. Well, we try not to make things complicated and stupid, I will say.
Yeah, like the problem with C is that it's like old, and like, and it's both overspecified and underspecified in the same time.
And this is fair. It's the thing is like we're not doing things where that becomes a problem. We're writing loops and conditionals.
Yeah, I understand, but like, I still don't like that language.
All right, fair enough.
Yeah.
There really aren't that many options for us, to be fair, at the moment. Like, there really aren't that many things we could use.
I mean, there is Zik.
There is, but it's like
some-
it's like the new trendy thing that isn't a great idea to build a whole thing.
Yeah, I
Right.
understand. I understand.
Yeah.
But like, probably cost of switching is going down right now, like by a lot.
I mean, I'd be more
Just-
excited about like better compile tools and stuff than I would about the language because I really don't need the features. You know?
No, I don't. The things I hate about C the most are something like build systems.
Yeah, CMake
They are-
we've been looking at if we have to include CMake or not, and I hate the builds. Yep, that is completely fair.
It's not it's not just the fact that C build systems suck. Is that there is like a dozen of them, and then you like look at something like Quick, a C compiler. You probably I don't know. I'm not sure if you saw it. And it has something like Lua script that generates Ninja files.
That's awful.
As a
Yeah, we
build
would not
system?
do that. The most we would even look at would be CMake. Currently, we have build.sh is what we have. The only reason that we're looking at CMake is it's not even necessarily because of the C, as much as that it's a pain to interact with Python and C. And if we had a CMake, it would allow us to delete our really obnoxious setup.py.
Yeah. But like,
Otherwise, I'd just keep the build.sh.
I mean, build.sh has its own problems. Like, what if I want to use Windows?
Then you use a real operating system. We support Linux and Mac. That's it.
Okay, what if I want to use
dope-based.
real shell instead of bash? I don't know.
I don't know. Use the normal shell. Stop being fancy.
I mean, you could always type in bash and then the script.
Yeah, that's
No,
what
no, I know.
That's
I
what we
know. I'm
do.
just I'm just bitching. Sorry.
Look, I mean, I have lots of people complain on these things, but it's like, yeah, okay, Zig is generally fine. Like if Zig were like the main thing that people like, if it weren't not this like new trendy thing, we would look at it. We'll absolutely not look at C++. We're not going to look at Rust. We don't need the main thing that Rust does is not something that we need. It just gets in our way. So
I understand.
yeah, so that doesn't leave very many other things. And I will say that like these environments that we've been writing in C, this has literally been the easiest programming has ever been for me. It's like literally easier for me now to make like the best RL environments out there than it is to do basic stuff in Python.
No, I totally understand
Yeah.
why you chose C.
Mhm.
I like it's just kind of irrational. I don't know, something at my sides.
Well, we also have to
Right.
tell people not to submit dumb PRs, and I see filter some of the people, but we still have to like, no, don't go crazy with macros. Stop it. No, no doing that. Right? Stop going and digging up every single feature in the C specification. Stop doing that. Right?
I mean, C doesn't have macros. It has templates.
Okay, whatever. The pound character forbidden. Okay, stop using
Yeah,
pound
I
character.
understand.
You can use it for constants if you must. That's all. That's pretty much all we do.
Sorry.
I think that somehow this version of the hyperparameter sweep does worse, which is disappointing.
Oh. That.
I included the full training history as training data for the sweeps. I don't know how that would make it do worse. That seems weird to me.
Okay.
Yeah, it's predicting, I can see it's like kind of crashed out here. It's predicting very low scoring stuff, which is very weird. So there's still more work to do on this. Big deal. Hey, it's hard to do, it is hard to make the best hyperparameter tuning algorithm. It takes some work.
Oh, I just went to your stream and realized that you're a Neptune enjoyer as well.
We support Wannabe and Neptune, but I've been much more, like, Neptune has been way better.
Yeah. Understand.
Now, they are missing some stuff. I've been trying to get them to add heat map coloration to their points. Like, I would like to be able to color them with a heat map based on time, so then I could see which points are being added to this when they're being added.
Mm-hmm.
So if you just do a heat map coloration, so like you start with blue and then you go to red as you add new points in, then if I were to look at like this Pareto frontier, I'd basically be able to see which portions of the Pareto frontier are filled in at which point in the sweep. So you basically cheat a third axis in your plots, except it's still really readable.
Okay. Yeah, I understand.
So there's some fancy, like there's some visualization features I want, but it's pretty nice for what it is. And it's really easy to download your data. That's, I think, their best feature. You do offline analysis. Like if their plots don't work for you, you just download your data in one command, and then you make your own plots.
Which is great.
This is very weird. Well, there'll be time for more analysis on this tomorrow. Let me just make sure I haven't missed any DMs here. I'm going to have to go to dinner shortly.
By the way, which stream has the lowest latency?
Which what?
Which stream has the lowest latency?
Probably Twitch.
Okay.
Well, if you're on Discord and you're watching the stream with the audio on, you're gonna have a bad time. Like you should mute the stream.
Yeah,
right?
I did that.
Yeah.
I did that.
It's probably Twitch has the lowest latency and lowest chat latency. It depends. Sometimes I have the most viewers on Twitch. Usually it's the most on YouTube. It depends.
Hmm.
I don't know. It's fun streaming though. I usually have like a few people watching me throughout the day, and then occasionally it spikes up to like 10.
That's not nothing.
It's not nothing
Given if
considering that I'm literally just like writing like intricate research code most of the time.
yeah, like given the fact that how much you stream.
Yeah.
Okay, I can't find your Twitch. It's like
I think it's J Suarez 5341. Yeah.
okay,
Same as my
Oh.
GitHub and everything.
okay, yeah. It's that.
Apparently I have 100 followers.
Any paid? Oh, like congrats with around 100.
It's funny. I mean, it's. I wish X had the view counter. I don't think people watch streams as much on X. They just kind of like notice that they exist. But the main following I have is on X. X is at 6931. I think the YouTube has like a couple thousand or something, but that's mostly they mostly were from my thesis defense. Because this thing has 160K views, so we have almost 3K subscribers there. I don't really make too much YouTube content. I experimented with it, but it's very like hit or miss with the algorithm.
I mean, like, and it's like labor intensive.
Yeah.
And
I mean, the goal is not ad revenue either, right? Like, this literally only benefits me if it gets like puffer users or like, if it gets us more business as well.
I mean, like, you probably would want to do like shorter video. I don't know.
I mean, we do.
Like,
X has been the best, honestly, for business contacts so far.
oh, definitely. Like, YouTube is not
Mhm.
that great for business. Like,
No.
because
It's
it
only
lacks
great
the
if
ends.
something really blows up. Like occasionally something will really blow up, right?
Mhm.
Like my thesis video, a lot of people saw my thesis video.
Yeah, and it landed you a bunch of credibility.
Yeah. Well, it's fun, I posted my defense. It's like this is what I did. Right?
Yeah.
Heck, my whole
Se-
thesis is online as well. You can go read it.
17,000 runs in
Oh yeah, we've
how many
probably had
months?
more than that. It's probably last couple months, maybe. That's mostly on one GPU as well.
Which GPU do you have?
4090. I mean, we have a blog on here. So like this is our cluster right here. This is our scuffed cluster right now.
Oh, how? Okay, so it's like 9 machines.
Yeah. 8 of them
And
with
what did?
4090s. Mhm.
And the 9th one?
Just a login node. It's got like a really old, like original V100 in it.
Oh. I mean, V100 is not that bad of a GPU, to be honest.
I think it's the original. It was released in like 2016 or 17, I think.
I think 17, like
Yeah.
in January. Like I remember, like when like usually GPUs came with like 8 teraflops or something, and then like they added tensor cores, and like Nvidia releases 100 teraflop GPU, and like
Yeah. Honestly, though,
we
most of the stuff at the time didn't make use of the tensor cores effectively. So like, yeah.
I mean like tensor cores didn't get used until like massively used until like 2019, 2020, like that.
I mean, there's probably a lot of headroom in Puffer as well. Like still, like you could probably make our training way faster than it is as well. We just haven't gone too deep into it.
Definitely, like you could just like do it train with torch, right?
Yeah.
You probably could just put R1 on your kernels, and it might be faster.
We could put what in our kernels?
How do you say it? Like, have you seen that NVIDIA stuff that where when they like used R1 to like massively speed up default kernels?
Oh,
I mean, they
Like,
use
I
like
didn't
R1
believe
to write
that.
Triton kernels,
Yeah,
right?
I didn't believe that. I like you're telling me that it's done better than their hand optimized, like their existing hand optimized kernels for existing
uh,
operations.
mm, like here's the thing. It's not that hand optimized for many of kernels because they are like just torch compiled to kernels, and like you don't do that much hand optimizations with that.
Hmm, that's weird. I don't know. I think
Like,
probably launch overhead is the biggest thing for us because I think we do like 200, at least 200 data batches per second, if not more.
mhm,
I mean, we do a million step per second training, right? And like if we have the eval batch size is like 4096, and then maybe we have a train
mhm,
mini batch size of 8,000 or 32,000 at most, probably
mhm.
16,000. So it's like there's a lot of launch overhead associated with that.
Oh, yes.
Yeah.
Oh,
I mean,
you
the nice thing is Puffer is
probably.
fast, so like if you use bigger models with lower launch overhead, it'll scale like better than you would expect normally.
Uh,
Um,
wait, you might take advantage of Grace, actually.
of which
Of Grace Hopper. Like,
the GPU series? What?
yes, like GH200 because they have like way lower latency between
Aren't
GPU
they
and
also
CPU.
crazy expensive?
Buck 50 per hour on Lambda.
How much do they cost to buy?
I don't know, but buck 50 on Lambda.
Superchip server. How are they a buck
Like,
50 on Lambda if they are $41,000 chips?
I mean,
How do they rent these things? They're losing money.
nobody knows how to use them, so they put like 3 months of discount on them, and
Hmm, it's
like
funny.
50% off, and go on like learn what to do with them,
Hmm.
and
Do they
like
run Torch out of the
it's
box, I wonder?
yes, it can run Torch out of the box, but it
Hmm.
couldn't run VLM like 2 months ago,
Oh. So
and
yeah, we
like
could try
other
that technically. That'd be funny.
and like it's ARM stuff, and there is a bunch of issues with like interaction of ARM with Python.
Oh wait, this is Grace CPU.
Yes,
What?
like because they are on the same package, latency is way lower, and like
Oh, I see.
Oh, that's actually really good.
That's like what
yes,
Digits is gonna do, right?
That actually would be pretty big for us if that worked.
yeah,
Unfortunately, they're
so
never
that's
going to
why
release like the thing is they'll always 10x the price because this is a consumer card.
uh
You can
probably
rent them, I guess, for
digits
now.
Yeah, in
gonna
theory,
work.
Digits would do the same thing, right? When it comes out,
It's obnoxious.
as long as it's not like 10K, right? I think the price leaks for like
It's
4K, right?
So our full
no, it's
servers cost Our full servers cost around 5.5K right now.
digits is 3K roughly, but
Oh,
it's
okay. Yeah, Digits is 3K, so that's not too bad.
Digits. Oh, but that thing
Yes.
was like, the perf on that thing looked terrible.
Yeah. I mean,
I
I think it's built for LLMs pretty much. So
like
we're.
for inference, but like, wait a
I mean,
second.
but you're gonna have a lot of memory transfer from CPU to GPU
Mm-hmm.
during RL applications, and so
Huge amount.
maybe because of that, you might just get some strange performance just from
Okay,
not having to do with so many
I mean,
transfers.
we can just rent on whatever. It's Puffer is just a container, so we can just download our container
Yeah.
on anything and just test it. I threw it on a vast 4 GPU instance yesterday to test the new
Mhm.
multi GPU, and yeah, we have in dev multi GPU gives linear speed up at least 200K to 800K step per second on like one of the M's.
Yeah. When for my puffer setup, I just did the torch distributed and on the puffer, and it just worked. Like,
Oh, you
it,
already been
it was,
doing it? That's cool.
yeah, I've been doing it for months.
Oh, we just added it to dev. Dang it, you should have PR'd that stuff, man. It helps us.
Well, I mean,
Uh,
I mean, it's not, and I didn't do anything crazy. The only thing I did
Oh.
was like I took clean RL, the torch distributed there,
mhm.
and then I made my environment using normal. The only using the normal setup. The only thing I had to do was make sure that the num workers on the vector I had to make the num workers lower than the CPU core count. But aside
Oh,
from that,
did you do distributed data parallel or data parallel?
uh, I don't even
We
remember the
got
difference at this
distributed
point.
data parallel working. And yeah, that probably makes sense with the CPUs. The thing is our M's are so fast that most of them they need 1 or 2 cores.
Yeah.
okay.
Like it's actually kind of crazy the extent to which we can make like cool sims that are fast. So Neural MMO3, this thing runs at 1.9 million steps per second per core.
Mm-hmm.
Like the logic of this thing. And like this is where is it? This is like massive world. You know, however many agents, it'll scale linearly with number of agents.
Okay. By the way, how often do you use cache grind?
How do I use what?
Cache grind.
Cache grind? Never heard of it.
Yes. Like stuff that lets you see your cache misses and stuff. But like,
Oh, not at all. Yeah, we don't like
okay.
literally, but this is the thing. This is what I'm saying. You do like the most brain dead, simplest possible stuff in C, and you still get this level of performance.
Oh, okay.
So that's what I mean by it's easy. No, it's literally easy.
Okay.
It's not. I'm not a genius. It's just that people are writing Python code that's 1,000 times too slow.
Yes.
Like
I mean,
that's
Python
it.
could be faster, but it takes some effort to make Python faster.
It's
Where
it's harder than just writing the thing in C.
Yeah.
what did you
Oh.
have to do the multi GPU? Like, what did you change?
Like
I'm kind of wondering if
15
you did
lines.
anything smarter. Yeah. Oh, yeah. So it's not much. Like,
No.
it just kind of worked for me.
Yeah, I mean, I integrated it as a separate option in the demo file so that you could like run with the existing in PufferL.
Oh, interesting.
A few other things. I also the logging needed some work, and I think there's still a couple things with logging. So that the dashboard will print aggregated stats. There are a couple things you'd have to do there, but
Mhm.
that's about it. Look at this.
By the way,
Live PR.
about one thing about digits, it's like 30% of 5090 in flops.
In
So that's a
terms of
terrible deal.
flops.
I mean, like depends. I don't know.
I mean, I'm gonna be honest with you. It's probably I think it's a good deal, and the reason is because I mean, if you're in RL world, maybe not, but if you're in the NLP world, it's like the biggest models, like the cheapest way to run on them is like a $20,000 Mac Mini at this point.
It's ridiculous.
I think it's epic. Like the cheapest is kind of epic.
Yeah, I mean, like a Threadripper is what you're saying, like
No,
with like a. Hmm?
literally epic server motherboard with 2 CPUs,
Huh.
Yeah,
and
so
like
like
you have
like a Threadripper.
No, Threadripper is different stuff. Like
Those
it's
are
a different
expensive.
lineup. Yeah, they are expensive.
So these boxes, we're planning on buying 40 of these.
Oh,
So we're
You
with
guys have
59
funding?
is
How are you guys like structured?
no, we're not VC funded. It's bootstrapped. A lot of it's from personal cash, but we do have revenue. I mean, we have clients.
mhm.
Nice.
I mean,
I'm hoping
it's
to
not
be
an amazing
one
business
soon.
model. It's like this is not a business model made by somebody who likes money, apparently, because we have all of our stuff open source, and like we make stuff so easy that we make ourselves redundant half the time. But yeah, it's literally just starting 10K a month for priority service. You get a slice of my time looking at your problem, and then it goes up from there based on how far outside of existing puffer stuff you need, and then if you need if you need additional contractors on stuff, because I pull in my PhD buddies as contractors.
I see. Interesting. Yeah, I'm hoping to be a client soon, or at least my client's hoping to be a client soon.
Hey, awesome.
Yeah, we'll see where it goes. It's basically we're getting I posted a video of it of our system working now. We're gonna scale into 3D eventually, and it starts getting really hard.
Let me see. What did you post?
It was a while ago. Hold on.
I might be able to
I'll
give you a quick rundown of stuff. Yeah, I mean, it's pretty much our goal is to just be the place that makes RL easy for folks, and to be able to sustain like a small profitable industry lab.
Yeah, this is what we got so far. I just linked in general I pinged you. I posted it a bit ago.
What is the task?
It's solar panel array optimization.
Oh,
And
cool.
so
Okay.
yeah, each one of those little blocks are solar panels, and then you have to lay out the wire in such a way that it's efficient for the person who's placing it. And right
Huh.
now, the people who are the people who actually write this are engineers, and they spend hours drawing these in AutoCAD.
That's crazy.
And so and it's a surprisingly difficult problem.
I mean, it's NP complete, so
But yeah,
Is this like obviously an NP complete thing? You can tell just looking at this.
I mean, it's pathfinding, so I think it's NP complete.
All right, I do not have yeah, I don't have a cache of NP complete problems in my head to map to. So
yeah, my brain goes like it seems easier than it is.
yeah,
It looks like it should be super simple, but it really isn't. And especially when you get into the more complex arrays.
well,
This
there's
one's a pretty good
structure.
complex one.
I think there's structure to it potentially.
Yeah.
Okay, I probably was wrong about NP complete, but still, it's still hard.
Yeah, we
We'll throw RL on it.
the founder spent like 3 years trying to generate an algorithm to do it
Huh.
for a while. And it doesn't really work. So I mean the best algorithm is RL at this point.
Oh, we can get some.
And
good
then
RL
eventually
working
we're
for
gonna
you.
go into 3D, but that's later.
Actually, since this is these look like procedurally generated layouts, as long as the sim is fast, we're doing new stuff. I think you probably heard earlier on curriculum learning. Like we're kind of doing research in a bunch of areas that are hopefully going to be applicable to various industry problems. This is cool, though.
Interesting. So what does that actually mean? I guess.
Basically, you would start with like smaller layouts of stuff, and the algorithm would be able to essentially bootstrap itself, so it learns way quicker to solve the harder problems by first learning to solve easier ones.
Mm.
Yeah.
Interesting.
Yeah, I mean, this is like the type of stuff we do for. Well, we do it for ourselves, but we also do it for clients as well.
That's
So
kind
like
of
you do
what
like
we're doing. to an extent. Like we start on smaller arrays and train it on that, and then we we keep stepping up and modifying the rewards and then training upwards because
Yeah.
the rewards that work for the problem like to solve aren't necessarily the rewards that work for the problem to be optimal.
Yeah, so I mean that's curriculum learning in a nutshell there, and there are better algorithms and smarter ways of doing that. That's actually one of the active areas of research that we have in Puffer right now.
Interesting.
Yeah, that's a fairly new effort, but like for instance, we have a procedurally generated maze environment that we use as a test bed for this.
Mm-hmm.
So you can start with these simpler mazes and then solve harder ones.
Mm-hmm.
Mhm.
I'm also it's 7, so I should probably go grab dinner. But yeah, that's a cool environment. Let me know how that's progressing. 'Cause we can definitely do stuff for that.
Yeah, I mean that'd be great. We're getting pretty close to we're actually doing our full alpha release.
Oh,
That's
great.
I think a couple of months ago. We have what makes it really complicated is there's a that's just a single string length of I think we have 12 in that one, but it has to support multiple different string lengths, and you have to be able to select it. In other words, the model has to be able to select it, and so it gets
Yep.
really crazy really fast. But we're getting really close, and once we scale into 3D, we're hoping that we can bring you on, but we'll see how that goes.
Yeah, let me know how that goes. Is the company like a startup or a larger company or?
Startup.
Okay, cool. I have special terms for startups as well. So if I need to bring contractors on, they ask for cash, but I take cash or equity. So sometimes that's a little easier on companies.
Oh yeah, that'd be really cool.
Mhm.
Sorry.
Yeah. All right. Well,
Cool.
nice talking to you. I'm actually gonna go eat too.
Yeah, great chatting. I gotta go get dinner, folks. So I'll just do the YouTube outro and or the YouTube/Twitch stream outro, and yeah, I'll chat with you all later. So for the folks
All right.
online, all this stuff is free and open source. You can check it out on puffer.ai. Go ahead and start the GitHub. Really helps us when people start the GitHub. It's one of the main metrics that we track. You can join the Discord if you want to get involved in discussions like these, or use the library, or contribute back to it. Don't really need a huge, any real experience in RL. A lot of the people have come in just with software engineering background. We help train people in that area. And if you're looking for more content, we've got a blog, and you can also follow me on X, where there are a bunch of articles you can't find anywhere else. It's the main place I post news as well. Thank you, and I will probably be back. Yeah, I probably won't be back after dinner. I'll be back tomorrow morning as soon as I'm up.
A question.
Mhm.
One question. Are those F# files in MOBA?
There are no F# files in MOBA. That sounds horrible.
Oh, sorry. What is .fs? Is like
Fragment
what
shader.
shader language?
That's just GLSL.
Oh, it's GLSL.
It's just
So
GLSL.
okay.
And it's just for like that's not used at all during training. That's literally the only reason that GLSL is there, just to show you. It's just decoration. So for the Puffer MOBA, there's this like wavy background you can see, and then also like the edges of the tiles, they like glow and they have this edge on them that glows and like fades. And there's also like this it's just for decoration. It makes all this stuff pretty.
Oh,
That's all it does.
okay.
Yeah.
Yeah. My code counting utility,
Yeah, that's all it is.
misunderstood that for F#.
We do not have anything
like-
crazy. Yeah, we really don't have anything crazy.
I understood. Like I looked at
The background in
the
this is a
thing-
shader technically. That's pretty much it. We don't have this is the most complicated shader that we have. Everything else is pretty straightforward. Like the background tiling here is a shader. That's it.
yeah, like all shaders are like 300 lines of code together.
Yeah, they're tiny. It's 20,000 lines of C, around 10,000 lines of Python, and a few small odds and ends. That's all PufferLib.
It says that it's like 16,800 of C. Yeah, it's not that much.
16,000.
Wow.
It should be more than that. It should be When we counted it, I think we have it in the demo trailer.
I mean, like I don't. It doesn't count blanks and it doesn't count comments.
Probably that. Yeah, it was probably 20,000, just like file length.
Yeah, file length is 20K, but like actual meaningful code is like 17K roughly.
Not bad. 17K lines for like a dozen environments. Actually, we just pulled in another big end contribution, and then there's one more that's almost ready to be PR, so it will be 20K pretty soon. We've got contributors building cool stuff.
What was that, Anne?
It's
that you pulled in?
a 3D maze environment. It's like a 3D puzzle environment.
Oh, yeah, that he talked just now. Let's talk
Spencer's
about just,
environment. Yeah, it's in dev. I think it's tower
Okay.
climb. But I do have to go to dinner now,
Mhm.
so it's good chatting. I'll
Okay.
be back on tomorrow.
Bon appetit. Bon appetit.
Thank you. Bye bye.